tree diagram is another useful way to determine the prime factorization of a number. Personally, I prefer it to a division table because it doesn't require me to divide only by prime numbers. I can divide by any factor that's obvious to me. In this case, 33,250 has many factors, so I encourage you to use the two that are most obvious to you. I used 10 times 3,325. If your two factors were different, don't be alarmed. Your final answer will be the same as mine. Whatever factors you use, though, you'll have to take each of them and continue to break them down to their prime factorization. 10, for example, can be written as 5 times 2. Those are each prime numbers, so I can stop there. When I continue working at the 3,325, again, use any two factors that are obvious to you. I use 5 times 665. 5, as we noted before, is prime, so that number is done, and I just have to break down the 665. Again, I use 5 times 133. 5 is prime, so I'll circle it, be done with that, and continue to break down the 133. It took a little bit of testing. 133 is not divisible by 2, it's not divisible by 3, and it's not divisible by 5. So I tested it with 7, and 7 and 19, which are both prime numbers, multiplied together to make 133. Once you've broken your number down like this, you're done. Be sure to list out your answer as 5 times 2 times 5 times 5 times 7 times 19. We need all of those prime numbers to be the prime factorization. Another option would be to write them in numerical order. 2 times 5 times 5 times 5 times 7 times 19. As you know, when it comes to multiplication, it doesn't matter which order you multiply the numbers in. So whether you've written it like I have in the first case or the second case, both are correct.